In this review tape, we're going to go over our work on solving systems of equations. Now, this is just a review tape, and we're just going to be going over examples rather quickly. If you want to see these examples explained in more detail, we suggest you go look at the original videotape lessons on solving systems of equations. Okay, for our first example, we want to solve for x and y. And we have the following system: 4x minus 3y equals 17. 5x minus 7y equals 31. 4x minus 3y is 17. 5x minus 7y equals 31. This is, let's say, equation 1 and equation 2. All right, now the trick is to multiply. We want to eliminate a variable. So we want to multiply the first equation, both sides, by some number, multiply the second equation also through by some number, so that when we add, one of the variables, either the x or the y, will drop out. We will eliminate one of the variables. And we'll just solve a first-degree equation in one variable, and then we'll substitute back to get the other. Okay, so we have a variety of ways of solving this. One thing we can do is to multiply the equation by 5 and the second equation by minus 4. Okay, 5 times the first equation would give us 5 times 4x, 20x. 5 times minus 3y minus 15y equals 5 times 17, 85. And if we then multiply the second equation by minus 4 times the second equation, we get minus 4 times 5x is minus 20x, minus 4 times minus 7y is plus 28y, minus 4 times 31 is minus 124. And we did this so that when we add these two equations, 5 times the first and minus 4 times the second, we see that we have a 20x and a minus 20x. The x's will be eliminated. We get 28y minus 15y, which is 13y, equals minus, now plus 85 minus 124, we get minus 39. Then we can simply solve for y by dividing both sides by 13. We get y equals minus 3. And then we can substitute into either equation 1 or 2 to find the variable x. Let's say we substitute into 1. Substitute in 1. You get 4x minus 3y, but y is minus 3, equals 17. 4x plus 9 equals 17. Subtracting 9 from both sides, 4x is equal to 8. And if 4x equals 8, we divide by 4 to get that x equals 2. And we believe we have found the solution. X equals 2, y equals minus 3. We now go back to the original equations and check. Strictly speaking, I guess you could just check in 2 since you found x, okay, from substituting into 1, but it doesn't hurt to check into both of them. Just make sure you haven't made a mistake somewhere here. X equals 2, y equals minus 3. Let's check. Okay, in equation number 1, we'll get 4 times 2 minus 3 times minus 3 should be equal to 17. And that gives us 8 plus 9 equals 17, which checks out. And in the second one, we have 5 times x, or 5 times 2 minus 7 times y, which is minus 3, should be equal to 31. And that gives us 10 plus 21, which does equal 31, so it checks out. So we have found the answer. X equals 2, y equals minus 3. Okay. In our next example, once again, we want to solve for x and y. And we have x over 2 minus y over 3 equals 2. And x over 3 minus y over 4 equals 1. Okay, two equations and two unknowns. X and y both appear only to the first power. The only problem here, of course, is the fractions that we did not have in the last example. A good idea in a case like this would be first to clear the fractions. Let's multiply, say, both sides of the first equation by the LCD, okay, in this case 6, just to get rid of the fractions, and in the second equation multiply through by 12 to get rid of the fractions without concentrating whether you can eliminate variables by doing that. Don't be so clever. Just get rid of the fractions, and then we'll worry about eliminating variables in the next time. Okay, so if this is, let's say, equation 1 and this is equation 2, we can multiply by 6. If we multiply both sides by 6 here, we get 6 times x over 2. That gives us 3x minus 6 times y over 3 is minus 2y equals 6 times 2, which is 12. 3x minus 2y equals 12. And as I mentioned before, here we're going to multiply through by 12. 12x over 3 gives us 4x minus 12y over 4 minus 3y equals 12 times 1, or 12. Okay, now it looks like the first example, and we can decide how we're going to multiply through in order to eliminate one of the variables. Okay. So let's see, we can take the top equation and we can multiply by 3, and the bottom equation by minus 2. That would give us a minus 6y here and a plus 6y here, and the y's would be eliminated when we add. Last time we eliminated the x's, it doesn't matter which one. We could have also multiplied here by 4 and here by minus 3 to get a 12x and a minus 12x. So you have a choice. Okay, so let's take the top equation and multiply through, let's say, the top one over there, and we'll multiply by 3. And then the bottom one we're going to multiply by minus 2. Okay, if we multiply the top one by 3, we get 3 times 3x, which is 9x. 3 times minus 2y is minus 6y equals 3 times 12, which is 36. Please remember to multiply the right side as well. Each term gets multiplied, in this case by 3. Okay, the bottom equation is getting multiplied through by minus 2. Minus 2 times 4x, that's minus 8x. Minus 2 times minus 3y is plus 6y. Minus 2 times 12 is minus 24. And now when we add the equations, okay, the y's drop out. We get 9x minus 8x, or x, equals 36 minus 24, or 12. You can then substitute into either equation. Let's say we substitute into the original equation 1. Substitute x equals 12 in equation 1. That would give us 12 over 2 minus y over 3 equals 2, or 6 minus y over 3 equals 2. We can subtract, you can either multiply through by 3 to get rid of fractions, or subtract 6 from both sides. If you subtract 6, you get minus y over 3 equals minus 4. Subtracting 6 here. 2 take away 6 gives us the minus 4. And now multiply both sides by minus 3. If you multiply both sides by minus 3, minus 3 times minus y over 3 gives us just y alone. It isolates y. Minus 4 times minus 3 is 12. So we get y equals 12. So we believe we found the answer here. X equals 12, y equals 12. Let's go back and check in the original equations. Here's equation 1 and 2. Okay, so we're checking x equals 12, y equals 12. In equation 1, we get 12 over 2 minus 12 over 3 should be equal to 2. 12 over 2 minus 12 over 3 should be equal to 2. 12 over 2, that's 6, minus 12 over 3, which is 4. And of course, that is equal to 2. In the second equation, we get 12 over 3 minus 12 over 4. That should come out equal to 1. 12 over 3, that's 4. Minus 12 over 4, that's 3, equals 1, and that checks out. So we have found the solution. X equals 12, y equals 12. Okay, in our next example, solve for x and y. Three x minus 5y equals 2. 5x plus 2y equals 7. Equation 1, equation 2. Okay. Now we're going to eliminate one of the variables. We can eliminate the y's. We can multiply the top equation by 2 and the bottom one by minus 5. By 5. Okay, if you multiply by 2, you'll get minus 10y. If you multiply by 5, you'll get plus 10y, and they'll cancel out. So we want 2 times equation 1 and 5 times equation 2. So multiplying the top equation by 2, we get 6x minus 10y equals 4. Multiplying the bottom equation through by 5, 5 times 5x, that's 25x plus 10y equals 5 times 7, 35. And we add, we get 31x, the y's drop out, equals 39. Dividing through by 31, we get x equals 39 over 31. And your first impulse is that you must have made a mistake somewhere, because how could you possibly get an answer like that? But there's nothing wrong with this answer. It does not have to come out to be a whole number, and you shouldn't get upset. However, when you get an answer like this, you have to consider the best way for finding the other variable. Now, in all the other problems, what we did is we went back, we took this value that we found, say for x, substitute into one of the equations, and then solve for the other variable y. And you say, look, I'm dealing with 39 over 31. Perhaps there's a better way of doing it. Okay, and you have another option. You can substitute if you want to, but another thing that you might do is to go back to the original 2 equation, and this time, instead of multiplying through and eliminating the y's, you can pick numbers to multiply to eliminate the x's. So you're still working with whole numbers. You're not working with fractions. And when you eliminate the x's, you'll find the y value that way. Okay, so let me just mention that and show you how to work it out. You go back to the original problem. You say, well, what would I have to do to eliminate, in this case, to eliminate the x's? Okay, so I have a 3x and a 5x, so I can multiply the top equation through by, say, minus 5 and the bottom one by 3. Okay, so minus 5 times the top equation and 3 times the bottom equation. Okay, minus 5 times the top, 3 times the bottom. Minus 5 times the top gives us minus 15x plus 25y equals minus 10. And 3 times the bottom equation, 3 times 5x, that's 15x. 3 times 2y, it's 6y. 3 times 7, that's 21. And now when you add, the x's do drop out, and you get 31y equals 11. 21 minus 10, that's 11. Okay, and you were able to work with whole numbers to find that, okay, which you might prefer to, say, substituting in this fraction into one of the equations and solving for y. Of course, you can still check this. You just go back to the original equations. It looks terrible. It's not so bad because both x and y have the same denominator, 31. And if you want to go through it, we can put the check right over here. Okay, 3x minus 5y equals 2. 3 times 39 over 31 minus 5 times 11 over 31 should be equal to 2. 3 times 39, that gives us 117 over 31 here, minus 55 over 31 should be equal to 2. And you do get, when you subtract 62 over 31, which, of course, is equal to 2. So that one checks simply enough. And in the other one, 5x plus 2y equals 7. 5 times x, which was 39 over 31, plus 2 times y, 11 over 31, should be equal to 7. 5 times 39 gives us 195 over 31 here, plus 22 over 31 should be equal to 7. 195 and 22 gives us 217 over 31, which should be equal to 7, and this does work out. Okay, this is 31 times 7 does give us 217. It works out. Okay, so we've checked that. So you do have that option of going back, first eliminating one variable, then go back to the problem, and then eliminate the other variable, rather than taking your value, which might be, say, a fraction or something complicated to work with, and substituting it in to find the other value. Now let's try a slightly more complicated problem. I want to solve for x, y, and z. I'm going to give you 3 equations with 3 unknowns. Okay, let me start it up over here. Solve for x, y, and z. And we have 3 equations in 3 unknowns. We have 2x plus y plus z equals 5. 3x plus 2y minus z equals 8. And 5x plus 3y plus 2z equals 13. Okay. Now, the way of handling 3 equations and 3 unknowns is basically try to bring it down to 2 equations and 2 unknowns, which you already know how to solve. And what we do is we take a pair of equations. Let's say we take the first and the second, and we try to eliminate a variable. In this case, it seems that we can eliminate z very simply, but we added the first and second equation. Okay, so we took the first and second equations, that pair, we eliminated a variable. You then take another pair, and you eliminate the same variable. Now, you have 3 possible pairs. You have 1 and 2, 1 and 3, and 2 and 3. So we took 1 and 2. We eliminated z. So you then either take 2 and 3 or 1 and 3, a different pair, and eliminate the same variable z. That'll give you 2 equations and 2 unknowns involving x and y, which we then solve by the methods that I've already shown you. So let's get into this problem. Okay, if you wanted to eliminate z, as I mentioned, from equations 1 and 2, the simplest thing, you don't have to do any multiplying, you just add 1 and 2. And you get a new equation, just let's label it 4. Okay, and 1 plus 2 gives us 4, and that's 5x plus 3y equals 13. We add 1 and 2, we get 5x plus 3y, the z's go, equals 13. So we'd like another equation involving only x and y. All right, so we can look at equations 2 and 3. That's a different pair. And what we can do is we can take equation 2 and double it, multiply through by 2. That'll give us a minus 2z here. And then add it to equation 3 and we'll be all set. So I'm going to take 2 times equation 2. That'll give us 6x plus 4y minus 2z equals 16. 2 times equation 2. And then just rewrite equation 3 underneath it. 5x plus 3y plus 2z equals 13. And then when we add these, we get 11x plus 7y equals 29. And let's label this equation 5. So we have now equation 4 and equation 5, 2 equations in the same 2 unknowns, x and y. Now let's go over what we did. We took a pair of equations, 1 and 2. We eliminated the variable z. In this case, we just had to add them. Then we took a different pair, like 2 and 3. Try to eliminate the same variable z. Since this has a plus 2z and a minus 1z, all we had to do is multiply the second equation through by 2 to give us a minus 2z. When we add, the z's drop out, giving us this equation 5. So we have equation 4 here, and let's write down equation 5 right underneath it. 11x plus 7y equals 29. Okay, now we have to decide how to eliminate one of the variables here. And let's say we want to eliminate the y. We can multiply the top equation through by 7 and the bottom equation through by minus 3. And the y's will drop out when we add. Okay, so let's try that. I'm going to take 7 times equation 4 and minus 3 times equation 5. 7, this equation 4, 7 times equation 4, 7 times 5x is 35x, 7 times 3y, 21y, equals 7 times 13, 91. And now minus 3 times equation 5, minus 3 times 11x is minus 33x. Here, minus 3 times 7y, minus 21y. Minus 3 times 29 gives us minus 87. And when we add, we see the 21y and the minus 21y drop out. We get simply 35x minus 33x, 2x equals 4. And dividing through by 2, x equals 2. Okay? And then we simply go back to either of the equations involving 2 variables. Okay, we know x. We go into either of the equations involving x and y, and we find y. And we know x and y. We go back to any of the original equations involving x, y, and z. We now know x and y, and we'll find z. Okay, so if we substitute x equals 2 into equation 4. X equals 2 into equation 4. That was 5x plus 3y equals 13. 5 times 2 plus 3y equals 13. 10 plus 3y equals 13. Subtracting 10 from both sides. 3y equals 3, and dividing through by 3, y equals 1. So we now know x and y. And we go back to any equation. Let's now go back to, say, equation number 1. So now we're going to substitute x equals 2 and y equals 1 into equation number 1. 2x plus y plus z equals 5. So 2 times x, which is 2, plus y, which is 1, plus z equals 5. 4 plus 1 plus z equals 5. 5 plus z equals 5. And subtracting 5 from both sides, z equals 0. Okay, so we believe that we have found the solution, namely x equals 2, y equals 1, and z equals 0. Let's check that by going back to the original equations. We're checking x equals 2, y equals 1, z equals 0. And we can just do that very simply here. X equals 2, y equals 1, z equals 0. 2 times 2, that's 4, plus 1, 5, plus 0 equals 5. That works out. Checking 2, 1, 0. So 2 times 3, 6, plus 2 times 1, 6, plus 2, 8, minus 0 is 8. And finally, 5 times 2, 10, plus 3 times 1, 5, plus 2 times 2, 10, plus 3, 13, plus 0 equals 13. So it does check out. Okay, so we were able to find the solution. X equals 2, y equals 1, z equals 0. Okay, now, in all the problems we've worked out so far, the variables only appear to the first power. We're working out linear systems of equations, and we saw 2 equations and 2 unknowns, and 3 equations and 3 unknowns. And now we're going to consider adding some nonlinear equations into the systems. Okay, and in problem 5, we want to solve for x and y. The system x squared plus 2y squared equals 11. X minus y equals 2. Okay, equation 1, equation 2. Now, the business of elimination doesn't work well when you don't have a variables with the same degree. See, when you had the x's in x here and x here, you could, try to subtract or add so that the x's drop out. When you have an x squared and an x, okay, it's not going to work so nicely. So instead, we're going to solve this by the method of substitution. We'll decide which is the easier equation to work with. In this case, it looks like the one without the squares. Okay, x minus y equals 2. It's the easier equation. We will solve this for, in this case, x or y, whichever is easier, and it doesn't matter. You could say x equals 2 plus y, or y is x minus 2, whichever way you want to work it. And then substitute in that value for x or y into the other equation. This will give us a quadratic equation in the variable, and we'll solve, we'll get the solutions. Now, whereas in the 2 equations with 2 unknowns, we could get, okay, we've seen graphically we could have either 2 lines intersecting at one point, or they might not intersect at all, so you have no solutions, or the lines might be really the same. The 2 equations might be of the same line. The lines fall on top of each other, and there's infinitely many solutions. Okay, we have different possibilities that can come here when you have nonlinear systems. If you make a little sketch of what's going on here, you can sort of figure out how many solutions to expect. The top equation is that of an ellipse. I'm not going to get into, sketching with the coordinate axes, but something like that. And we have the bottom equation is a line. Okay, so we would expect something like this could very well happen. In other words, two solutions would not surprise us in this instance. In fact, that's exactly what we're going to get. Okay, there's always the possibility, of course, that the line does not meet the ellipse, in which case there is no solution, or the line could be, in fact, just touching the ellipse at just one spot, and there'd be one solution. But this is the usual possibility, the usual thing that occurs here. Okay, so let's solve, designating, say, this the simpler equation. We can say solve x equals y plus 2. Okay, that's from 2. We solve for x. We now take this value for x and substitute back into equation 1. Okay, substitute into equation 1. We have x squared plus 2y squared equals 11, y plus 2. So y plus 2 squared plus 2y squared equals 11. Expanding, y plus 2 squared, remember, is y plus 2 times y plus 2. You just don't say y squared plus 4. Okay, it's y squared plus 4y plus 4, using FOIL, plus 2y squared equals 11. Y squared plus 2y squared, that's 3y squared plus 4y minus 7 equals 0. Just collecting the terms on one side. Let's go over that. The y squared plus 2y squared gives us 3y squared. The 4y we have here. The 4 and the 11 on the other side, we subtract 11 from both sides, and we get the minus 7. Okay, so we have a quadratic equation. 3y squared plus 4y minus 7 equals 0. And we can solve this by factoring. A little fooling around here, and we get 3y and y, the only way to make 3 and 1. Now the question is, do you put a 7 here and the 1 here, or the other way around? And it factors this way. 3y plus 7 times y minus 1. This gives us 3y squared minus 3y plus 7y is the plus 4y minus 7. Okay, we have it now factored, so we can set each factor equal to 0. This gives us y equals 1. This gives us 3y is minus 7. Y is minus 7/3. Okay, now we have the setup for getting the two different solutions. We're going to substitute back into our simplest equation here, x equals y plus 2. Okay, substitute into x equals y plus 2. Okay, if you substitute y equals minus 7/3, you get x equals y plus 2, x equals minus 7/3 plus 2, or minus 7/3 plus 6/3. Think of this as 2 over 1. We want to combine fractions. We need the same denominator. So we change 2 over 1 into 6/3 by multiplying top and bottom by 3. This gives us x equals minus 1/3. And here, y equals 1. X equals y plus 2. We get x equals 1 plus 2. X equals 3. So we have two solutions. We have x equals minus 1/3, y equals minus 7/3, which you can designate as the point minus 1/3 minus 7/3. Recalling our graphic approach to the problem, this would be one of the points of intersection if you were to sketch these. And the other one is x equals 3, y equals 1, the point 3, 1. And we can check these. The equations, just reminding you, the original equations were x squared plus 2y squared equals 11, and x minus y equals 2. Okay, this one is very simple. 3 minus 1 is 2. 3 squared, 9, plus 2 comes out 11. And this one over here, x minus y minus 1/3 minus a minus 7/3 minus 1/3 plus 7/3, 6/3 does come out to be equal to 2. And this one requires a little bit more work. X squared would be 1/9 plus 2 times y squared, which is 49 over 9. And that gives us 1/9 plus 98/9, which is a total of 99/9, which comes out to be 11. And all the other ones, as I said, you could sort of do in your head. So we check each point in both equations. Okay, so here are our two solutions. Just one more thing on this problem. Don't develop your own version of elimination. Some people think that they can somehow just square the second equation and get this to be like an x squared plus y squared equals 4 and then do elimination. It doesn't work that way. We know when we square the left side here, we would have x squared minus 2xy plus y squared. Okay, and the right side would be 4. So just, there is no shortcut around this. Okay, now sometimes you can do elimination